Welcome back. Today we're going to talk about solving equations. Okay, all of the equations that you're going to see today are called first degree equations in one variable, and all of these equations contain two types of terms or two types of items in the equations. There's constant terms. These are terms that are just numbers. Okay, and there's terms containing the variable that is raised to the first power only. All right. Another way of describing first degree equations in one variable is they're also called linear equations. So these two are equivalent definitions. Now, so let's go over what we just set up here. These two equations here are examples of first degree equations. Now, they're first degree because every variable I see, so in the first one I only see one variable, and it is raised to the first power only. Okay. If I had this variable and it was raised to the second power, it would be called second degree equation. If I had a variable raised to the third power in my equation, it would be called third degree equation, and so on and so forth. So both of these equations are similar. Now this equation has two y variables, but both the y variables are raised to the first power, and it says in one variable. What that refers to is that there's one type of variable. So in both of these, there's only an x in this one and there's only an y in this one. We are going to see equations later on where we have x's and y's. So for instance, this would be a first degree equation in two variables. Okay. All right, so the equation below is not first degree because it has a variable to the exponent. Because there's a variable in the equation raised to an exponent greater than 1. So this, for instance, is called a second degree equation because of this term, right? This power right here. So you have x squared. It doesn't matter that there's an x to the first power here. What matters is that this is actually going to dominate the equation here. This x squared term is going to dominate the equation. So this is called a second degree equation. So the ones that we're going to deal with today are first degree equations. We're going to see several different types. Okay, so example number 1. We have an equation with one variable and we need to solve it. Now there's a few different ways you can solve it here. So the first thing you want to think about is using keep change change, so that technically it becomes negative 3t is equal to 24. Okay, 15 plus negative 3t. Now you do that because actually if you don't do that, so let's say that we just went and we started to solve this. The first thing you want to do is subtract the 15 to isolate the variable. Well, when you have a subtraction problem, you can't technically take away the minuend and leave the subtrahend because you still have to deal with this operation. So yes, a shortcut is to think that it becomes negative 3t is equal to 9, but that's because really the intermediate step is to do this step using keep change change. Now, you don't have to show this step, but what you do have to remember is that that step is happening behind the scenes. So you can subtract 15 from each side and carry this down as negative 3t, but remember that this is a subtraction sign, and the sign of the term here, 3t, is positive. But if you use keep change change, it becomes an addition sign with a negative. It becomes the operation of addition with a negative sign on the term here. Okay, so you can do this, but just remember that behind the scenes, this step is going on behind the scenes. Okay. Now to isolate the variable further, we would divide each side by negative 3, so you have t is equal to negative 3. Now you know this is correct because if you go ahead and put this back in, you would get, whoops, actually I don't need to write the t because I'm substituting the value of t back in for the t in the original equation. So really what you did when you solved it is you said that t is equal to the number negative 3, because if I put this back in for t, then I would get 15, and this ends up being plus 9 is 24. So that's correct. Now remember that behind the scenes here would be 15 minus, and 3 times negative 3 is negative 9 is equal to 24. But with keep change change, it would be 15 plus 9 is 24. Okay, so I've solved the equation. When I solve the equation, I want you to put a little box around your solution or a little circle around the solution. And if I ask you to check, always write the word check above it so that I know that you're running it through the equation. And you put a check next to the, once you know that the left-hand side is the equivalent to the right-hand side, you can put a check next to the solution here. Okay. Okay, here's another example. Now, in this example, the y term is being divided by 5, and then 3 is being added to it to get a total of negative 2. So what you want to do here is you want to use, in order, the orders of operations going forward is PEMDAS. Okay, so in order to invert all the operations, you want to use SADMAP, which is PEMDAS written in reverse. Okay, so get rid of any subtraction and addition first. Okay, then get rid of any multiplication and division, then exponents, then any operation that's occurring inside parentheses. Okay, so these are your steps. Okay, so we have addition in this equation, so we want to isolate the variable by subtracting here. And then we have negative 2 minus 3 is negative 5, and that's equal to y over 5. Now there's a few different ways, so we've done the first box here, we've done any subtraction and addition. Now the second box is division and multiplication. So y is being divided by 5. I want to get rid of that. There's a couple different ways you can think about it. You can either multiply each side by 5 over 1. Okay, and that gets you, these are going to cancel, and you have y divided by 5, which is, sorry, y divided by 1, like this, is equal to negative 25 over 1. Well, that's just y is equal to negative 25. Okay. Another way to do it, which I've seen students really enjoy in the past, or they really prefer this method, this was our equation here. What they do is they actually make proportions. So the right-hand side is a ratio of y over 5. You can only do it when the right-hand side, the side with the variable, is just a ratio. You can't have that plus 3 on the other side. It doesn't work like that. So I put the left-hand side over 1, and here I can use the cross products. We have negative 5 times 5 is negative 25, and y times 1 is just y. So all I did here was use the cross products, like this, okay? Because when you have a proportion, you know the cross products are equal to each other, right? And so we get the same answer here. We can sort of, I'm not gonna perform the checks here because it would just make the video too long, but remember that you can always put this number back in for y and divide it by 5, add 3, and you should get negative 2. Okay, all right, this is an equation where you have an expression on top here being divided by 3, and that's equal to 4. Now again, a quick way to do this is actually just to make proportions. So I have a ratio on the left-hand side, I can make a ratio on the right-hand side, and all of a sudden I'm allowed to use the cross products. So here we have these cross products here. Okay, so we have negative 6 minus 2x times 1 would just be 6 minus 2x is equal to 3 times 4 is 12. Now we have an equation similar to the first one we saw. We can subtract 6 from both sides. We have negative 2x. Remember, the negative 2x is being brought down because it's plus a negative 2. That's equal to 6. Divide by negative 2, cancels here. X is equal to negative 3. Okay, so a quick way to do this is just pull out those proportions. Okay, we have a coefficient that is a decimal here, so that's something that's maybe sort of new to you. So first thing I want to do is I want to get rid of any addition and subtraction. So I have 0.8r is equal to 1. Now in order to deal with this, you can either divide both sides by 0.8, or I always like to put my decimals in terms of fractions. I think it's easier that way. Okay, this is 8/10 r. The other equivalent to this would be 8r over 10 is equal to 1. And it's equivalent to that because if you think about the coefficient being multiplied by the variable here, well, r can be over 1, so you just have 8 times r, which is 8r, and 10 times 1, which is 10. Okay, so again, I can just throw this into a proportion. So 8r, you have 8r is equal to 10, or r is equal to, divide each side by 8, 10 over 8, r is equal to 5 over 4. Okay, and I'm just going to keep it in terms of a fraction, of an improper fraction. But it is simplified, so just make sure you do that. Okay, our next example is an example where you have to simplify. This is the first time we've seen in this video where you have to simplify a side before you move on. So instead of subtracting 8 first, there are like terms that I can combine on the left-hand side here. So these two are like terms. I'm going to go ahead and combine them. Okay. Now there's nothing else to simplify on either side. So when you work with equations, you want to think about each side as an expression first, right? Because an equation is two expressions that are set equal to each other. So so this is expression 1 and expression 2. If there's anything to simplify on either side in terms of the expressions, then you want to do that first. Okay, I made this thing a little bit longer because there's no need for me to make it that long, really. The expression happens to be a constant, but it is two expressions equal to each other. Now I can start to work with either side. Negative 1x is equal to 16. Divide by negative 1 or multiply each side by negative 1. That's equivalent. Okay, so here I divided each side by negative 1, but remember the other thing I could do is multiply each side by negative 1. Okay, because negative 1 times negative 1 just gets you 1, and 1x is just x. So these two things, these multiplying and dividing by negative 1 are the same thing. Okay, I have an equation, again, where I have to clean up the left-hand side before I start interacting between the sides. You never want to start interacting with the sides until you've cleaned up one of the sides, okay? So, or you want to think of it in terms of expressions before you think about it in terms of equations. So here I have this expression on the left-hand side that I can simplify. All right, now remember, if you have subtraction with a number outside of a grouping symbol, you want to use keep, change, change in order to change this into plus a negative 3. Now when you distribute, you're distributing the negative 3 into the terms here. So you have 27x plus, this would be negative 6x, and this negative 3 times 10 is going to be negative 30, but in conjunction with this subtraction sign, it's going to be positive 30. And that's equal to 23. Whoops. Okay. Now here I can add these two together to get 21x plus 30 is equal to 23. So now that I have the left-hand side, there's no like terms I can simplify or no grouping symbols I can eliminate. So I'm ready to go ahead and have the left-hand side of the equation. I'm ready to try to isolate the variable is what I'm trying to say. So after I've cleaned up the left-hand side, I can use my inverse operations to isolate my variable. So I have 21x is equal to, this would be negative 7. I divide by 21 for both sides. Now be careful, this is not negative 3. That would be 21 divided by negative 7. This is negative 1/3. So if I divide each numerator and denominator by 7, I'd get negative 1 on top, and I'd get 3 on the bottom, divided by 7. Okay, so x is equal to negative 1/3. And remember, it's good practice to always go ahead and perform a check, but it would just make our video too long, so I'm not going to do that. Okay. This is the first equation in this video where we see variables on both sides. So look at my expression on the left-hand side. Expression 1 is already simplified. Expression 2 is already simplified. So before I even start to isolate the variable, because I have variables on both sides, I want to get the variables just on one side and the constants on the other side. Okay, and you've seen this before in 7th grade. Now, in order to do that, my strategy is always to take the smallest amount of the variable and subtract it from both sides, because then I end up with a positive coefficient to my variable. Okay, but it doesn't really matter. You could have a different strategy. There's many different ways to do this. So I take the 3x away from the left-hand side, so I have 7 is equal to 6x plus 10. So notice now all my variable is on my right side. Okay, I have no more of the variable on the left side. So now I'm trying to isolate the variable, so I have the variable on the right side. Let's get all the constants on the other side. So I have 6x is equal to 17. I divide by 6 from both sides. So I have x is equal to 17 over 6. And in this situation, I don't get an integer as my answer, and that's perfectly fine. I get an improper fraction. In algebra, you want to start to leave things as reduced improper fractions. You don't have to turn them back into decimals. We rarely leave things in terms of mixed numbers unless we have to plot them on a number line. So I'm just going to leave it like this because there's no way to simplify this. Okay, here's another one where we have to, we have variables on both sides, and we have to clean up the left-hand side. So this expression can be cleaned up. There are some like terms here. So if I use some keep change here, I can change it like that. 3b plus negative 5b is negative 2b plus, and this is going to be negative 2, is equal to, and then I'm going to clean up the right-hand side while I'm at it. We have 12b minus 44 here, because the right-hand side can be distributed, right? Now we have variables on both sides. So what I'm going to do is I'm going to add 2b to both sides, because I looked at both 12b and 2b, and I realized that if I added 2b, I would get a positive 14b here, and I like to work with positive numbers. Okay, so I'm going to add 44 to both sides. So I have 14b is equal to 42. Now they must be, let's see, so 7 goes into both of them. So let's think about this here. So this is, let me reduce it by 7. So this would be 6 over 2, but that reduces to 3. So b is equal to 3. Okay. Just a couple more examples here. So here I have to clean up the left-hand side and the right-hand side. So here I'm going to use distribution. And here I want to use keep change to make this plus a positive 7. Okay. I have variables on both sides, so I'm strategically going to make my coefficient positive by adding 2x. I'm going to subtract 7 from both sides. And divide by 6. Now x is going to be equal to 1 over 2. Okay? And that was my last equation. So you've made it through the entire equation video. Congratulations. And that's the end of the lesson for today.